Hey everybody, this is our study guide. I'm going to go over just in case the recording from the live does not work. So here we have number 1, Addison is playing a board game. The probability that Addison will score a point on her next turn is 3/4. What is the likelihood that Addison will score a point on her next turn? So that means look at the probability line and see where 3/4 fall, and we see that 3/4 will be in this area here, in this section here, so it is a likely probability that she will score a point on her next turn. Number 2 here, probability can be expressed as a number between 0 and 1. So again, when we have this probability line, it always goes from 0 to 1, which is why we use a lot of fractions and decimals. Now you can convert it to a percent, but you have to remember that it's between 0 and 1, not 0 and 100. Always between 0 and 1 whole certain that it will happen. Number 3, Ethan spins a spinner that has numbers 1 through 5, and we have several things we're going to do here. Name an outcome that is impossible. If it can only land on 1, 2, 3, 4, and 5, then landing on 0 is impossible. So is landing on 6 or 10 or anything else you want to put. Name an outcome that is likely. So likely on our probability line has to fall only in this section here. That's wrong. Other way. This section here. Likely. So we want more than a 50% chance. An easy way to do that is to list all of your outcome, and there's 5, so more than 50, choose 3. It could have been these 3 or it could have been this 3. Doesn't matter, but I could say landing on 3 through 5 is very likely. Any number between 3, 4, and 5. Name an outcome that is unlikely. Again, you can list them out, or you can just choose one of the 5. So landing on 1 would be unlikely because there's only 1 out of the 5, and 1/5 is on that probability line under unlikely. Name an outcome that is certain, that will always definitely happen. That means landing on a number between 1 and 5 or landing on a number under 6 will always happen. You had some variability in these answers, but hopefully you can come up with situations that are always true. Some things that I saw on the study guide were in the flip grid. Be careful when you're choosing it. Just make sure you truly are over the 50% line for likely, under the 50% line for unlikely, and then something that'll never happen and something that'll always happen. So make sure you're thinking through those possibilities that you wrote down on your study guide. All right, next one, we have a bag that contains 3 blue markers, 5 green marbles, 5 white marbles, and 7 red marbles. What is the probability of selecting a white marble? That's it. Show your answer as a fraction, decimal, and percent. So probability of selecting a white marble is favorable outcomes over total outcomes. There are 5 white marbles over 20 total marbles when you add them all up, and that reduces to a 1 in 4. That would be your fraction. Change that into a decimal by dividing 1 divided by 4, and then change it into a percent by moving it over twice. 25% chance. Which of the following events would have an equal chance of occurring? Select all that apply. Equal chance of occurring. That means the probability is going to be the same. Spinning a spinner with 4 equal sections. 4 equal sections means there's a 1 in 4 chance for each of those sections. Rolling a die, there's a 1 in 6 chance for every face of that die. So does these equal? No, these do not equal. rolling an 8-sided die and selecting a marble from a bag of 8 marbles. First one, rolling an 8-sided die, there would be a 1 in 8 chance. Selecting one marble out of a bag of 8, there would be a 1 in 8 chance. So these have the same equal chance of happening, so B is good to go. Tossing the coin and choosing an even number between 1 and 6. When we toss a coin, there's always a 1/2 chance. Choosing an even number between 1 and 6, you have 2, 4, and 6, which is a 3 in 6 chance, but that does reduce to 1/2. And 1/2 and 1/2 have equal chances of occurring, so that is also good. Choosing a letter out of the alphabet, that is a 1 in 26 chance. And drawing a red card out of a standard deck of cards, that is a 26 out of 52 chance, which is a 1/2 chance. 1 over 26 and 1/2 do not equal. So that cannot be an equal chance of occurring. So your only two right here are B and C. Jamie tossed a coin 80 times. The coin landed on heads 32 times and landed on tails 48 times. What is the relative frequency of landing on heads as a fraction decimal in percent? Relative frequency is just another word for probability of it landing on heads. It landed on heads 32 times out of the total 80 times that they tossed it. And then this reduces if you divide everything by 16 or keep dividing by 2 until you go down as much as you can. It is a 2/5 chance. And if we want to turn that into a decimal, put in your calculator 2 divided by 5 and you'll get 0.4. And if you want to turn that into a percent, move that decimal over twice and you will get 40%. School bus Connor rides is scheduled to arrive at his stop at 8:19 a.m. each day. The table shows the actual arrival times of the bus for several days that were randomly selected over the past few months. Based on that data, what is the probability that the bus will arrive at Connor's stop after 8:19 tomorrow? So we want to find the probability that it will arrive after 8:19. So the ones favorable to us are anything after, and then you just count them up. There are 13 stops after 8:19, or 13 times that it arrived after 8:19, and there were a total of 20 given to us in our chart, and that doesn't reduce, so you're done. 13 out of 20. A bag contains 50 marbles, some blue and some green. Suppose a student, without looking, chooses a marble out of the bag, records the color, and then places the marble back in the bag. The student has recorded 6 blue marbles and 14 green marbles. Using these results, what prediction can be made for the number of green marbles in the bag? Okay, so this was the trial right here. So if you were giving a chart, it would say blue 6, green 14. That's all that they did. All right, so we want to make a prediction out of green. There were 14 green marbles out of how many? That means how many times did he do the trial? So you have to add 14 and 6 together to get 20 total times that he chose out of that bag. So his probability was 14 out of 20 for green marbles. Now we're going to make a prediction, so we're going to use a proportion. How many would that be, the part, out of the whole 50 marbles? Then you're going to do cross multiplying, 14 times 50, and you're going to get 700. Other side, 20 times x, 20x. Divide both sides by 20 to cancel this out and have the x by itself, and then you'll get that x is 35. So there must be 35 green marbles, we're going to guess, in that bag. All right, number 9, Sam is conducting an experiment where he repeatedly draws a marble from a bag without looking, records its color, and replaces it. He conducted 40 trials in the experiment. The results are recorded in the table. If Sam were to conduct the same experiment with 500 draws, approximately how many times could he expect to draw a red marble? Sort of the same thing as number 8, but we're going to do it 3 different times. So for the first one here, red marble, in the table it shows that he has 16 red marbles out of the 40 times he drew. 16 over 40 is how many out of 500? Cross multiply 40x equals 8,000. Divide both sides by 40, and we can guess that there were 200 red marbles. Blue marbles, there were 14 blue marbles out of 40, and we want to know how many out of 500. 14 times 500 is 7,000 equals 40x. Divide both sides by 40, and x equals 175 blue marbles. Yellow marbles, there were 10 out of 40. We want to know how many out of 500. 10 times 500 is 5,000. 40 times x, 40x. Get that x by itself by dividing both sides by 40, and x equals 125 yellow marbles. So there's your answers: 200 red, 175 blue, 125 yellow. Number 10, Mr. Beecher places the names of his students in a hat, and in order to randomly call on students, there are 18 girls and 14 boys in the class. What is the probability that a boy will be called on? Show your answer as a fraction, decimal, and percent. So we have a simple probability here. What are the chances of it being a boy? There were 14 boys total. Out of how many? You had to add them together. 18 and 14 make 32. And that reduces to 7 over 16 when you divide by 2 on both sides. There's your fraction. 7 divided by 16 gives you 0.4375 as your decimal. I am not rounding. And then to make that as a percent, 43.75%. Nicholas spun a 4-section colored spinner 12 times. He expected to land on yellow 3 times, red 3 times, blue 3 times, and green 3 times. The spinner actually landed on red 5 times, yellow 2 times, blue 3 times, and green 2 times. What should Nicholas do in order for his experimental probability to be closer to the theoretical probability? And this is about the law of large numbers, which means just do it more times. The more you do the experiment, the closer that you will be to the theoretical probability. Number 12. A cookie company puts a colored ring in each box of cookies. There are 6 different ring colors. The colors of the rings are shown in the table below. Based on the data, what is the probability that the next cookie box will contain a purple or green ring? Purple or green. Or means to add. So purple we have 10, green we have 8. Together 10 and 8 make 18. Out of how many rings did they have total? They had 50 when you count them all up. All of these equal to 50. So 18 out of 50 were either purple or green. And then we can reduce that to 9 and 25. And there's our fraction. Simplified. 9 divided by 25 gives you 0.36. So there's our decimal. And moving that decimal place over twice, you get 36%. There's our percent. Number 13, Jenny wrote the names of her teachers on tags and put them in a bag. She drew a ticket, recorded the first letter in the name, and returned the ticket to the bag. The result of her experiment is AEWWGCEECWAEACC. What is the probability of W? Count them all up. 1, 2, 3 W's. So 3 are favorable to us. Out of how many letters are there total? There are 15 letters total. That reduces to divide both sides by 3 into 1 in 5 chance. How do you get the experimental probability to most closely match the theoretical probability of an event? This is exactly like number 11. The more you do it, the more that your probabilities will start to look closer together. Number 15, a bag of candy contained the flavors grape, sour apple, blue raspberry, and watermelon. Mason drew each piece of candy out of the bag and recorded the frequency of each. Which candy's experimental probability is closest to its theoretical? So here you have the experimental probability in a table. So the experimental is given to us. Theoretically, what should happen is there are 4 flavors, so each one has a 1 in 4 chance of being chosen, which is 25%. So if you count these all up, there's 106, so 21 out of 106. I'm going to put it as a decimal because it's easier to compare decimal. 0.198. Sour apple, 0.358. 38 divided by 106. Blue raspberry is 28 divided by the 106 total they gave us. That was a 0.264. And watermelon, 19 out of 106 is 0.179. Theoretically, they should have a 25% chance because it's a 1 in 4 chance since there's 4 flavors. So which one of these numbers is closest? 26.264 is the closest. So blue raspberry is the closest to 25%, 26%. So blue raspberry. Letter B says, which candy's experimental is furthest? So we're going to use the same work we just did, but which number is further away from that 0.25? And that would be sour apple. Sour apple is the furthest from 25. That's it. Lily's tossing a coin. She tosses a coin the 12 times and it lands on heads 7 times. If Lily tosses a coin a 13th time, what is the probability that it will land on heads? And when you have a coin, there is 2 sides. There's always a 1/2 chance. If I toss it 1, I'm still going to get one of the 2 sides. If I toss it a 10th time, I'm still going to get one of the 2 sides. If I toss it a 13th time, you're still only going to get heads or tails. One of 2 things could happen every single time you toss that coin. Number 17, Allie and Anna are shopping for shirts. The store where they're shopping offers 5 styles: long sleeve, 3/4 sleeve, short sleeve, muscle shirts, and tank tops, and 4 colors: black, white, blue, and gray. How many combinations are there? Well, there's 5 styles. And there's 4 colors. 5 times 4, using the fundamental counting principle, drawing a tree diagram, gives you that there are 20 combinations. That looks like 26, but it's 20 combinations. Letter B. What is the probability of picking the perfect shirt on the first try? You have a 1 in 20 chance. Out of all the 20, that's only 1 chance. A coin is flipped 5 times. What is the probability of getting heads all 5 times? So the first time you flip, the heads has a 1 in 2 chance. The second time you flip, the heads has a 1 in 2 chance. The third time you flip, you have a 1 in 2 chance of landing on heads. The fourth time you also have a 1 in 2 chance. And the fifth time you have a 1 in 2 chance. Now we are multiplying because we want to see the outcomes of these all happening at the same time. Can't get these dots to look right. So we're multiplying using the fundamental counting principle. Instead of drawing a tree diagram, you can multiply to get all the outcomes. So 1 all the way across is still going to equal 1 because we're multiplying. 2 times 2 times 2 times 2 times 2 is 32. So out of all the possibilities, there's only one that could be heads, all 5 coins. Ainsley is conducting a probability experiment. She is tossing a coin and spinning a spinner with 8 equal sections numbered 1 through 8. How many possible outcomes are there? All right, so if she's tossing a coin, there are 2 outcomes on a coin, heads or tails. And then she's doing a spinner with 8 sections, so we're going to multiply that by 8. And that means there are 16 outcomes with these 2 events. Number 20, Thomas flips a coin and spins a spinner. There are 12 outcomes in the sample space. How many different sections does the spinner have? So when we do a coin, he has 2 sections. When we spin a spinner, we don't know, but we know in total that he has 12 outcomes. So we're working backwards here, dividing by 2 to get that by itself, and we have that x has to be 6 total sides. So that spinner has to have 6. You can go back and check. 2 times 6 is 12. Describe a likely situation that each tree diagram could represent. You can have different answers here. I'm going to use the same things we've been using, spinners and dies and coins. If there are 6, 1, 2, 3, 4, 5, 6 in this first event, then I could say that this was a die. And then there were 6 in the next event, so I could say there were 2 dies being thrown here. On this one, on letter B, the first event had 6 outcomes, so find something with 6 outcomes. The easiest would be the die. And then in the second one, heads or tails, there was only 2 outcomes. So I'm going to say a coin. Didn't have to stand for heads or tails, but normally it does. Over here we have it started with heads or tails, so I'm going to say it started with a coin. And then it went 6 different ways. It had 6 outcomes, so I'm going to say a die. There's different things you could say here, but here's an example of one. With 3 students are chosen at random from Mrs. Morris' class that has equal numbers of boys and girls. She decides to perform a probability simulation to determine the likelihood that the 2 students chosen will be both be boys. Determine if it's valid or invalid. Selecting 3 cards from a deck that is half cards that are red and half black cards, using a red card to represent a girl and a black card to represent a boy. So everything within that deck, there would be a 26 out of 52 chance that it'll be a boy or a girl. So it is a good 50-50 chance, 1/2 chance that girls represent half and boys represent half. So that is a good experiment. That's valid. Rolling a number cube 3 times, using the number 3 to represent a girl and 5 to represent a boy. Both 3 and 5 have a 1 in 6 chance. However, what happens when I land on 1, 2, 4, or 6? A 4 in 6 chance, we don't know what it would stand for. So some of you thought that this was valid. However, this questionable that we don't know what happens is not a good experiment because you're going to be rolling over and over and over again. It would have been better to say that odds were boys and evens were girls, or the other way around, because odds and evens both have an equal chance of occurring. However, this unknown over here makes this not valid. Flipping a coin 3 times, using heads to represent a boy and tails to represent a girl. Both heads and tails have a 1/2 50-50 chance, no extra going on, so that is a valid experiment. Our particular event has a 40 chance of occurring. Using the numbers 1 through 10, fill in the blanks to create a scenario for a random number simulation. So our outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those are the only things that we can use. So there's 10 numbers we can use. Now we want a 40% chance of success. So because there are 10 numbers, it would be very easy to just say 4 out of the 10 can be successful. However, it doesn't have to be these 4. You just have to give me 4 out of the 10 because 4 of 10 is 40%. So if there were 20 numbers, then you have to find 40% of 20, which means you would have to choose 8 of those 20 numbers. So make sure you're using the actual ratio 40%, and because we have 10, that means I have to choose 4 numbers to have success. So I'm just going to very easily choose the first 4 numbers. Numbers 1 through 4, we're going to indicate success. That means 5 through 10 is going to indicate failure. I could have chosen 7 through 10, that's still 4 numbers, to be successful, and 1 through 6 indicate failure. It doesn't matter what numbers, as long as 40% of the numbers are successful. Number 24. A bag contains 3 blue, 1 red, 6 green, and 2 clear bouncy balls. Bouncy ball is drawn and not replaced, and then a second bouncy ball is drawn, was probably green and then clear. I believe this was on our quiz, or one of the things we've done. So here we go. We want green first. There are 6 green out of how many total? You have to add them all up, and there are 12 total. The second time, and then, which means we're going to multiply, we want clear. However, that ball is not replaced, so it goes down by 1. We already lost 1 out of the bag, and then now we are favorable. We're looking for clear, and there's only 2 clear left in there. 6 times 2 is 12. 12 times 11 is 132, and both of these can be divisible by 12, so there's a 1 in 11 chance. If you turn that into a decimal, it's 0.09. If you turn it into a percent, it's 9%. There you go. Last one. The table below represents the 36 total possible outcomes for rolling 2 dice. List the possible outcomes of rolling a number less than 3 and then an odd. So the easiest way I can show you this is to use a highlighter here. We want a number less than 3. I'm going to use this as my first roll. So the numbers less than 3 would only be 1 and 2. Now that we have these as our first roll, that means any of these can happen in the first time you roll. Less than 2, all of those in the first roll would be less than 2. In my second roll, I'm going to use these columns as my second roll. I actually want an odd number, so I have to take out my even possibilities, and then I'm going to go down. These are the only possibilities that I could get, so therefore I'm going to erase to show you this no longer applies, this no longer applies, and these no longer apply, and these couldn't have happened from the first roll. So the only 2 that could happen, only 6 actually that could happen, are a 1 and 1, a 1 and 3, a 1 and 5, a 2 and 1, a 2 and 3, and a 2 and 5. So these are the 6 outcomes. You could ignore the table and make a tree diagram if you want. So if you want a number less than 3, that means your first event you're going to have a 1 or a 2, and then the next event you wanted an, what was it, odd number. So there are 3 odd numbers on the die: 1, 3, 5, 1, 3, 5. And so you could read your events. Go with a highlighter here. 1 and 1 gives you 1, 1. 1 and 3 gives you 1, 3. 1 and 5 gives you 1, 5. 2 and 1, 2 and 3, and 2 and 5. So without using the table, you could have come up with the 6 total outcomes as well. That's it. Let me know if you have any questions on anything in your study guide. And then make sure you continue to practice with the resources I post on the blog for your test on Friday.